Hello, class ninth physics, chapter light and reflection by spherical mirrors. So about light and reflection, laws of reflection and other basics I have covered in another video. Um, so I'm not going to repeat that again. Link is in the description. So you can, if you haven't watched it, so watch it first, and afterward we can move further. So here I will start the topic with the concept of mirror. First, we need to understand what is a mirror. So whenever we hear the word mirror, the thing that comes in our mind is a glass piece, which is totally wrong. Actually, mirror is not a glass piece. How can we define mirror? Mirror is a smooth, plain, reflecting surface which has maximum regular reflection. So that it can form images which we can recognize easily. So the thing is, as I told you, a glass sheet is not a mirror. Then what is a mirror? So actually, mirror is a reflecting surface, a metal sheet kind of, a thin layer of that. So generally it is made up of silver, it is made up of aluminium, it is made up of tin, SN, and a few other chromium, nickel. So uh, depending upon the need, these coating material can be different. So we have to make a mirror, we have a thin lining, thin sheet, thin surface. Thin means about 1 micron, a few micron thin. Micron 10 to the power minus 6 meter. This much thin, somewhere close to this. A thin film, thin sheet, thin surface. And we call it lining actually. It is kind of a deposition over that glass surface. So because it cannot be stable if it will be put in that way. So I hope you people have seen that aluminum foil which we use to wrap our food. So even if you want to use it as a mirror, you can, but soon it just deformed itself. So in order to prevent that deformation of that thin sheet, we place a glass surface over it. Now glass is transparent, so uh, rays can easily pass through it and get reflected from this reflecting surface, which is made up of some metal and any among these. And then on the back side of this get painted. This is how we form a mirror. So actually that metallic thin film or metallic lining acts as a mirror, and that glass sheet prevents it. That back painted surface also prevents this metal lining. All right, so this is the thing, what mirror is. It is not directly related to your syllabus. Actually, manufacturing of this mirror is not in your syllabus. But just for a general idea, I have covered this topic here. So, mirror, how many types of mirrors are there? There are two types of mirror. I hope you people will say convex and concave. So, you are not totally correct. Actually, plane mirror and spherical mirror. Actually, curved mirror can be the answer. And among those curved mirrors, there can be spherical, there can be parabolic, there can be some other categories. But once again, I don't want to make a confusing part here, because these are not included in your syllabus. Only plane and spherical mirror are there. So I'm not falling into that much confusion. But I will cover many kind of mirrors in my upcoming videos. So be connected. Now spherical mirror, we can divide them into two parts, two categories. One is convex mirror and other one is concave mirror. Convex, concave, plane mirror looks like this, Actually, this is the way to represent a mirror. Reflecting surface, non-reflecting surface, or covered surface. Next, convex. This is the convex surface, reflecting surface bulged outward. And concave, reflecting surface depressed inward. So sometimes it is to memorize these things. People say that cave is always something which is there is inward in nature. So it is inward. Here cave formation is there, so that is how you can memorize this name concave, because sometimes it get confusing that what is convex or what is concave. So you can just resolve that confusion by remembering this cave word. So plane mirror, convex, concave. Now the question is, we know about plane mirror, laws of reflection hold good on plane mirror, but do they hold good for convex and concave also, and how? So we will check it out now. Before I will tell you how reflection takes place in spherical mirrors, first, a few important terms related to these spherical mirrors. In plane mirror, there is only a reflecting surface and nothing much is important in it. So whenever a ray incident on it like this, so at that time we draw a normal. So we require to define a normal, which is a line that is perpendicular to the plane of the mirror. That's all. So incident ray, reflected ray, that's all. Nothing more to discuss about this plane mirror. But in case of spherical mirror, there are several terms related to that mirror which are very, very important. So first, I'm talking about convex mirror. This is a convex mirror. Now, first thing, how is it formed? So it is formed. We can assume that it is a part of a sphere. So it is a part of a sphere. So where is that sphere? Assume that it is that sphere, and we have sliced it. So in actual look, it is not in two-dimensional. In three-dimensional, it looks like this, like a bowl. And this surface of that bowl is acting as convex surface. So it is like this, a surface, a spherical surface, a bowl type of surface. So this sphere has a center, which we call center of curvature. The midpoint of its surface is called pole, and the line joining pole and center of curvature is called principal axis. Main axis. That is why principal axis. So this is principal axis. Okay, principal, not the principal. Principal axis. And this is pole. And this is center of curvature. All right, so these are the terms related with this mirror. Other than that, there is its radius also. All right, so a definition for these terms, I'm stating them one by one, and in fact, I will write them also. So first definition is this. The midpoint of reflecting surface of spherical mirror is called its pole. I have used the word spherical. If it is convex, then replace it with convex. And if it is concave, replace it with concave. So next time I'm not going to tell you the definition of pole of concave mirror. All right, COC, might be thinking of something else anyway. Center of curvature. So its definition. All right, center of that sphere actually assumed. Okay, so that we have to assume a sphere, and from where we have cut this mirror. So center of that sphere from which spherical mirror is obtained is called center of curvature. In case of convex, you will use convex, and in case of concave, you will use concave. We will replace that center word with the radius. So radius of that sphere from which spherical mirror is obtained is called radius of curvature. So next thing, we have discussed about pole, we have discussed about center of curvature. principal axis. This is once again, I'm just stating, not writing there. The axis passing through pole and center of curvature. The axis passing through both the pole and center of curvature is called principal axis. So that is principal axis is simply a line which is passing through pole and center of curvature both. So next point, aperture. Few people call it aperture, but you can say it is not aperture in fact. So it is aperture. So what is that aperture actually? Aperture means the frontal side of that mirror. If I turn it, so it will look like this. So this frontal side will be called its aperture, like aperture of this. So this size, it is its aperture, frontal side. So how do we measure it? By measuring the diameter. So we can say the diameter of a spherical mirror is called its aperture, or we can say diameter of frontal side. Diameter of frontal side of spherical mirror is called its aperture. It directly relates with its size. Next thing, so till now all the definition which are being applicable on this convex, so also they are applicable for concave, but now things will changed. There comes a definition by which entire context of these. So next definition is focus, which I haven't drawn it here yet. But to be very smart, what we can do first, we will draw some rays on these mirrors, not only convex but also in concave. So here we have two mirrors, convex, concave, and you can see center of curvature of this lies here, and center of curvature of this lies here. Understandably, because if we follow this, sphere like goes like this, and if we follow this, sphere will not go that way, but it will come this side. All right, so and now we'll mark pole also. Okay, so now what happens actually, these spherical mirror also follow the law of reflection, but on the basis of that, first I am just explaining a point for both the mirror, and that is focal point. So first I briefly tell you about law of reflection, how they work on these spherical mirror, and later on we will discuss about them later on in detail. So let us suppose a ray incident on both the mirror. I mean a parallel ray. Here is parallel ray parallel to this principal axis. Here also parallel to this principal axis. Now what happens generally when we do have a plane mirror and it is the pole. Kindly ignore these messiness, and if ray incident on it, we draw our normal to the plane and reflect it. But for spherical mirror, how can we draw this normal? So remember one thing, whenever light get incident on these spherical surface, we draw normal from center of curvature. So from center of curvature, we will draw this normal, And now whatever with the angle this one was, so also the reflected angle. Actually, I just broaden it enough anyway. So if we produce it backward, we get some point here, which is called focus. Okay, in the same way here, first we will draw a normal to the plane. Actually, it is not the plane, but normal to the surface. Yeah, normal to the surface, and then whatever the angle it is, we will draw equal angle here, and it will pass. Well, I am drawing freehand. I'm doing freehand drawing. If you people will use geometrical instrument, then it will be easily done. Uh, all right, but yeah, actually, in the exam, schematic diagram is asked, not up to the scale. So you need to practice very hard, and you can draw them directly as I am drawing. No need for proper measurement, but to understand it very well, you need to initially use some geometrical instruments and all that. So this point is called focus. So for convex mirror, how will we define the point focus? So to define focus, so we can define focus of convex mirror by saying that the focus of convex mirror is the point on principal axis at which the rays parallel to principal axis appears to get diverged after reflection. Means it is the point on the principal axis from which rays parallel to principal axis appears to get diverged after reflection. In the same way, what is the definition of focus for concave mirror? The point on principal axis from which rays parallel to rays parallel to principal axis passes after reflection. So in or converges after reflection. So in convex mirror, we will use the term that it will get diverged from this point, and in concave mirror, we will say that it will get converged to this point. But remember one thing, in both the cases, you have to consider rays parallel to principal axis. So here it is, the definition for convex focal length of focal point of convex mirror. Focus is the point, and when we indicate it, we call it focal point. And then there comes a term called focal length. So the length between pole and focus is called focal length. Now in case of concave mirror, how we will change the definition? Entire this thing will remain same. The point on principal axis from which rays parallel to principal axis uh, appears to get diverged. In place of this, from here till here, we will write uh, rays parallel to principal axis converge. That's all. In here appears, and here it actually converges. So converge or converges depending upon what we have used the term ray or rays, whatever. So that's you can resolve yourself. So and then this will also get changed. that will be replaced by concave. So this is all about the focus. Now we have how many point pole, focus, center of curvature, and now we can understand how do these mirror undergoes reflection. One thing I have told you that each time when we draw normal, we have to draw it from the center of curvature. Why is it so? I will tell the reason at the end of this video. It is totally mathematical reason actually. So before I will tell you, before I would tell you about the image formation by these two mirrors, an important diagram and very easy diagram. Actually, two important diagrams or very easy diagrams are there. One is diverging action of convex mirror. Now, what is diverging action? We know that in the definition of focus, for convex, we have used the word divert. Divert means spreading outward. So, first I will draw principal axis and a convex mirror. Here its center of curvature C, here its pole P, and here its focus F. So diverging action, actually if there are number of rays incident on the convex mirror, these much are enough. So actually no need to draw those many normals right now, otherwise it will be very hodgepodge here. So all of these will get diverged along these lines. So put the scale here and produce it further. Put scale here, that your ruler, and that's all. So this is diverging action. In the same way, converging action of concave mirror. Here it is C, here it is F, and it is P. So these are the rays. So they will pass through the focus. And this time it was apparently happening, but this time in actual it will take place. So this is converging action. This is converging action. And this is what if as I have taken one of the ray and defined focus for both of them. So these are diverging action, converging action, 1 mark question, maybe 2 mark question. Let's see how to image formation take place, but before that, how do rays behave with these spherical mirrors? So maybe it will be a problematic set of diagrams for you students. There I am drawing 3 convex mirrors, and on other side I am drawing 3 concave mirrors. Okay, I will first finish this. Alright, so all the initials I have done. Now First case, the most common cases I am taking. Ray can be parallel to principal axis. Second thing, ray can come from somewhere toward the focus, or it can exactly pass through the focus. In case of concave, it can pass through the focus. In case of convex, it will appear to come toward the focus. Third case, it can pass toward the center of curvature. And here, third case, it can pass through the center of curvature. Now, how will the rays behave? Well, we know this case. As I told you, first draw normal from here and then draw a reflected ray with equal angle. But to be very tricky, as we know that ray parallel to principal axis appears to diverge from the focus. That's all. This is the first case. So sometimes these diagrams as such form, they come in the exam and you are asked to complete the ray diagram. So that's all. And in the same way, if we retrace it, so actually the rays are reversible. This reflection is reversible. So now the reverse thing will happen. Again, we will draw a normal and then the angle, that is the angle of incidence, and so angle of reflection will also same, and it will go parallel to the principal axis. And third case, it is going toward center of curvature. So as it is the same case as in the case of plane mirror, when light falls at a 90° with the plane, or we can say 0° with the normal, then it bounces back. In the same way, ray toward the center of curvature bounces back. As I told you, for normal you have to draw line from center of curvature. So line drawn from center of curvature acts as a normal, and here it is directly incidenting on the normal. Now in the same way, if you want to do it yourself, pause the video and do it yourself. All right, for if you have done, just match it out. So, oh, I have done it directly. First draw a normal and this angle equal to this angle, so it will come that way. And if it passes through the focus, again do this angle equal to this angle. It is possible if it passes parallel to the principal axis. Now it is along the normal because it is passing through the center of curvature, so it will bounce back. So other than that, one more thing can be there, but it is not no proper point are mentioned for this. If it directly falls on pole, so what is the issue? The angle of incidence equal to angle of reflection. It will directly go this way, because if it falls here, so already normal is drawn in the form of principal axis.